Let's say you need to build a routing engine for Bing Maps that can route people from one location to another over thousands of kilometers instantly. However, it needs to be super fast, cheap to run, incredibly reliable. It has to be able to dynamically update the route based upon changing circumstances and update to personalized preferences. Customizable Route Planning, or CRP for short, is a little known, simple, and powerful algorithm that satisfies all these requirements where every other algorithm fails. Finding the best route between two places on a road network can be turned into a graph traversal challenge, with junctions acting as nodes and roads as edges. The classic and simple Dijkstra's algorithm solves this brilliantly but takes a few seconds to run on continental sized graphs. So, there's been extensive research on how to speed up this by pre processing the graph in a way that allows quicker querying. The fastest technique is called hub based labeling, or HL, where each junction stores a time to each other junction, which means we can always pick the right next intersection to travel to by picking the closest junction to the goal. However, in the real world, if a road is blocked, HL will fail. It also fails if a user has preferences around ferry use, toll roads, walking, U-turns. For a routing algorithm to update to metrics rapidly, it must store very little data to recalculate cost functions. In addition, it must be able to handle alternate routes while being simple to maintain. First, we need to speed up for pathfinding over Dijkstra, but with a simple algorithm where heuristics can rapidly affect recalculation of a route. Hierarchical algorithms, the most popular solution to speeding up graph traversal, are extremely complicated and unreliable when heuristics are introduced. Instead, we use overlay graphs, which is where you partition a graph into sections and store the intersections between each subgraph. We can then plan a route across subgraphs 100 times faster than using Dijkstra due to the smaller node count. Finally, we need to handle dynamic heuristics. The most common heuristic is when the traffic of a road increases or decreases, and we need to reroute the shortest path around the traffic. With hierarchical graphs, this fails as we have pre-computed all of the costs for each road and area. However, because we are still just doing Dijkstra's algorithm on our overlay graphs, we can just relabel the affected nodes, weights, and costs and then rapidly rerun Dijkstra. To validate CRP is superior to all the other algorithms, we prepare challenges on a roadmap with dynamically changing traffic and toll preferences. We see CRP is still more than fast enough for practical use, while correctly routing based on preferences where hierarchical methods fail. Sometimes the fastest algorithm is not the one we want.